I'm working with a dataset that has 10 features, things I'm measuring, and one target variable. A simple yes, no answer, making it a binary classification problem. Think of it like trying to predict if someone will buy a product based on 10 different characteristics. I'll be using scikit-learn's f_classif function. It's a tool that helps me figure out which of my 10 features are most important for making accurate predictions. It does this by calculating an f statistic and a p-value for each feature. These are numbers that tell me how much each feature explains the variation in my yes, no outcome. A higher score suggests a stronger relationship. For example, a score of 15.2 indicates a much stronger relationship than a score of 0.8. These values are probabilities. They tell me the chance of seeing the f statistic I got if the feature actually had nothing to do with the yes, no answer. A really low p-value, much less than 0.05, suggests that the feature is likely important. I've set my significance level to 0.05, or 5%. This means I'm willing to accept a 5% chance of being wrong when I say a feature is important. Now comes the quiz. I need to figure out which statements about my feature selection are true, given the f statistics and p-values and the significance level. Let's see if I can ace this. I have 10 different features, I'm representing them as x, and one binary target variable, my yes, no answer, which is y. I want to figure out which of these 10 features are the most relevant in predicting y. The main goal here is to use the f_classif function, a statistical test within the scikit-learn library, to determine which of the 10 features are most relevant to predict my target variable. I'm using a dataset with 10 features, which I'll call x, and a single target variable, y, that can take only 2 values. This is a typical setup for a binary classification problem. I've set my significance level, alpha, to 0.05. This means I'm willing to accept a 5% chance of incorrectly rejecting the null hypothesis. That is, concluding a feature is important when it's actually not. I see this option suggests selecting features with f statistic scores above 5. This is wrong. While a higher f statistic suggests a stronger relationship, the p-value is the ultimate decider, based on my chosen significance level. I need to check whether p-values are below 0.05. This statement proposes to select features whose p-values are less than 0.05. That's correct. That's exactly how we use p-values in hypothesis testing. This option claims features 0, 3, and 6 are definitely chosen. Let's examine this. I need to check the p-values for those features. If their p-values are below 0.05, then indeed they should be selected. It looks promising. This statement asserts that we can use only f statistics or p-values. That's incorrect. The f statistic and p-value give related but different information. The f statistic measures effect size, and the p-value gives the probability under the null hypothesis, which we use with the significance level to make a decision. We're working with a dataset. It has 10 features, which we'll call x through x, and a single target variable, y. That's either 0 or 1, binary. Think of features like the height and weight of a person, while the target might indicate if that person is healthy or not. This is a typical setup for a classification problem where I want to predict a class label, 0 or 1, based on multiple features. I'm using fclassif, a function from scikit-learn, a popular Python library for machine learning, to do feature selection. That's like choosing which of the 10 features is most important for predicting the target. It's like picking the most useful tools from your toolbox. These scores tell me how much each feature explains the variation in the target variable. A higher score means the feature is likely more important. They are the result of applying the fclassif function. These scores are obtained by performing ANOVA, analysis of variance, a statistical test used to compare the means of two or more groups. The p-value for each feature tells me the probability of seeing a result as extreme as I observed, if that feature was actually not related to the target. A small p-value, typically below 0.05, suggests that the feature is related to the target. The lower it is, the stronger the evidence against no relation. I've set my significance level to 0.05. This means I'm willing to accept a 5% chance of wrongly concluding that a feature is important, a false positive. It's a common threshold in hypothesis testing. This statement is correct. I'll select features with p-values less than 0.05 because that indicates they're statistically significant at my chosen significance level. This is partially correct. Features 0, 3, and 6 have p-values below 0.05. However, so does feature 9. It should be included in the list of selected features as well. I've set a significance level of 0.05. This means I'm willing to accept a 5% chance of incorrectly rejecting the null hypothesis, that a feature is unimportant. It's a common threshold in hypothesis testing. I'm working with a dataset containing 10 features, x, and a binary target variable, y. The features are the things I'm trying to select and the target is what I'm trying to predict. These are the p-values, which is basically the probability that I observed my results by pure chance, assuming that the feature has no effect on the target variable. The lower the p-value, the stronger the evidence that the feature is important. In this case, the first p-value is 0.001, meaning that the probability of observing my data if the first feature was truly unimportant is very small, 0.1%. These are the f-statistics, which measure the ratio of variance explained by a feature to the variance within groups. Higher values suggest that the feature is more strongly related to my target variable. But, I must still consider the p-values. This statement is correct. If a feature's p-value is below my significance level, 0.05, I reject the idea that the feature is unimportant. Hence, the feature is selected. This is also correct. Looking at the p-values given, features 0, 3, and 6 all have p-values less than 0.05 and hence are significant. Nope, this is wrong. While related, the f-statistic shows the strength of an effect while the p-value shows whether an effect is statistically significant. I need both to draw conclusions. This is incorrect. I can't just look at the f-statistic alone. A large f-statistic might not be statistically significant if its p-value is high. I need to consider the statistical significance which is captured by the p-value. I'm using a significance level, alpha, of 0.05. This is the probability of making a type 1 error, rejecting a true null hypothesis. In simpler terms, the risk I'm willing to take in saying a feature is important, when it actually isn't. This is the function from scikit-learn that I'm using for feature selection. It performs ANOVA, analysis of variance, to test for differences between groups based on each feature and outputs f-statistics and p-values. I'm working with a dataset that has 10 features, things we measure, and a single binary target variable, the thing we want to predict, which can only be one of two things, like yes, no or 0/1. I'm using scikit-learn's f_classif function, which is a statistical test that helps me figure out which of my 10 features are most important for predicting my target variable. It uses ANOVA, analysis of variance, to do this. After running f_classif, I get a list of f-statistic scores. Each score tells me how much that feature explains the variation in my target variable. Higher scores suggest a more important feature. The scores are 10.5, 2.1, 0.8, 15.2, 3.7, 1.2, 9.1, 0.5, 6.3, 4.9. Along with the f-statistic scores, I also get p-values. A p-value represents the probability of seeing the result I got if there were actually no relationship between the feature and the target. A small p-value, usually less than 0.05, means it's unlikely the result is by chance, so I consider the feature important. The p-values are 0.001, 0.15, 0.42, 0.0001, 0.05, 0.3, 0.003, 0.5, 0.01, 0.02. I've set my significance level, alpha, to 0.05. This means I'm willing to accept a 5% chance of being wrong when I say a feature is important, making a type 1 error. This statement is correct. I should choose the features with p-values lower than 0.05 because those are statistically significant. In simpler terms, the low p-value means it's highly likely these features are actually important for prediction. This statement is partially correct. Features 0, 3, and 6 have p-values below 0.05, 0.001, 0.0001, and 0.003 respectively. However, feature 9 also meets this criterion, p-value equals 0.02. This statement is incorrect. The f-statistic and p-value are connected but convey different aspects. The f-statistic shows the effect's size, while the p-value determines its statistical significance. This simply reiterates that there are 10 input features, x, and a single binary, 0 or 1, output, the target, y. This binary target variable is the thing I'm trying to predict using the features. This is incorrect. Simply having a high f-statistic score isn't enough. I also need to consider the p-value to determine statistical significance. I have a dataset for a classification problem. It includes 10 features, things we measure, and a binary target variable, a yes/no outcome we're trying to predict. I'm using scikit-learn's fclassif function. This is a tool that helps me pick out the most important features in my dataset for my classification task. These are the f-statistic scores that fclassif calculated for each of my 10 features. Each score represents how much that feature helps explain the variations in my target variable. These are the p-values, corresponding to the f-statistic scores. They tell me the probability of seeing such high f-scores by pure chance if the feature is actually unimportant. A low p-value is good. It suggests that a feature is really important. I've set my significance level to 0.05 or 5%. This means I'm willing to accept a 5% chance of being wrong when I say a feature is important. Based on my p-values and the significance level, I can decide which features are important enough to keep for my model. Features with p-values below 0.05 are statistically significant and I'll include them in my final model. I am working with 10 features, which are the variables that describe the characteristics of the data, and a binary target variable, which is a variable with only 2 possible values, for example, 0 or 1. It is the outcome I'm trying to predict.